Hey guys, Coperific here. Welcome to the final video of organic chemistry. So the thing we're gonna address about is free radical substitution of alkanes. So the words that are written in black shows the general formula for the general equation for free radical substitution. And one example is that methane gas can react with chlorine gas to form your chloromethane and your hydrogen chloride. And the cool thing about free radical substitution, and also considerably also another bad thing about it, is that it can also react with even more of these chlorine gas molecules to form other products like your dichloro methane, and then it can react further to form trichloromethane and also your tetrachloromethane. And combining these two equations, you can form this type of equation also. Okay, so in the sense that free radical substitution, you can form multiple products like this, 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 and this. Yeah. So if you have excess chlorine gas, you are more likely to form even more of your tetrachloro methane. Even if you have limited chlorine gas, in a sense that you can most likely it will stop at the formation for chloromethane. Okay, so the criteria of this reaction is that you need a halogen reagent like chlorine gas or bromine gas. It will be very hard to react iodine with your alkane because it's very difficult to produce iodoalkanes because the reaction is endothermic and energetically unfavorable. So if you do the calculations using your uh, the chemical energetics, you realize that breaking the bonds and the energy absorbed in breaking the bonds is more than the energy evolved from forming the bonds when it comes to the reaction with iodine. So that is why the reaction is energetically unfavorable because their products will be at a high energy level. So in a sense, the enthalpy change of the reaction will be a plus sign. Okay? Alright. Also another criteria is that you need and brief exposure to UV light. So energy is needed to initiate the homolytic fission of the the bond. It can be chlorine or it can be bromine bond to form your chlorine radicals or bromine radicals. So to recap on homolytic fission is actually the breaking of a bond between two atoms that are identical or have a similar negativity. So each bonded atom will, in this process of homolytic fission, right, it will involve the bonded atoms taking one of the bonding electron. So in a sense, this one will go to this, oh sorry, my bad. This one will go to here, and this one will go to here. Okay, and then it will cause them to form these free radicals which have unpaired electrons. So these unpaired electrons will make these free radicals very reactive because it will have a strong tendency to pair up with another electron of another species to form a covalent bond. So one thing to take note, when you draw arrows, this is how you draw. The half arrow indicates movement of one electron, and then the full arrow indicates a movement of two electrons. Okay, so this is a quick recap. So that is one of the reasons. So one of the reasons you need UV light is that the energy from this UV light will be able to initiate that homolytic fission. So you generate these chlorine radicals. And why you need these chlorine radicals? You just need a brief exposure of UV light because these radicals, right, you will initiate chain reactions of propagation step, and it will produce even more radicals to sustain the reaction. So when it's chain reaction means is that you notice how propagation step is always involve a radical and a radical reacting with a molecule or a species that is not radical, and it will keep forming radicals until the reaction comes to a stop through the termination step. So as I show you later, you'll be able to understand. Chlorine radical acts as a homogeneous catalyst. It will be consumed and regenerated again and has the same gaseous phase as the reactant. When I do this question with you, I will show you how it's being done. Okay, so as you can see right here, suggest a mechanism for the chlorination of ethane to form 1,1-dichloroethane. Okay, so let me shift this right here. I do not need a huge space. Okay. Oh no. So, oh wow. Alright. Chlorination ethane to form 1,1 dichloroethane. Okay. So what you're gonna do for this in approaching this question, right, is you need to ask yourself um what is this mechanism? So this mechanism, since you see there's an alkane and chlorine, which is a halogen, so definitely it will be a free radical substitution. So we start off with identifying the mechanism. It's a free radical substitution. Okay. Now the next step is to identify what is the product that we form right here. So the product that we form right here is 1,1-dichloroethane. So this is a di-substituted product, meaning it will two of the hydrogen atoms from ethane will be replaced with a chlorine atom. So let's draw out. I'm gonna use the green pen for rough working. So rough working here, no need to show in the answer. So usually one dichloroethane, longest chain. This is just two atoms. No double bond because it's just alkane. The two chlorine atoms is on the first carbon, and this is your molecule. Okay, all right. And this is a di-substituted product. So 2H 2H atoms from C2H6 is replaced. Okay. What is important about di-substituted product and mono-substituted product? So whether it's a di and mono-substituted, the most important thing is that you need to know that it's important to know how many atoms are being substituted, because this will determine how many equations you need to write. So remember that since it's a di-substituted product, so we'll be looking at this one over here. Okay, so initiation. How are we gonna draw initiation step? By the way, if you do not know the steps wise, you can just remember IPPT. So IPPT. Okay, so initiation, propagation, and termination. Yeah. So step one, initiation. So how we're gonna do this is, since it's chlorine, we draw out this chlorine. And initiation, remember, is about having the energy to initiate the homolytic fission of the chlorine-chlorine bond to form your chlorine radicals. So in this case, it will take each chlorine atom will take one of the bonding atoms, and under the exposure of UV light. It's very common to miss out UV light, so just remember, and you'll be able to form these chlorine radicals. So this is the most basic step. Now step 2 is propagation. So in propagation step, you always need to know it involves radical plus molecule will give you a radical plus molecule. So in this case, since we have this chlorine radical, what should we do next? So remember the remember that let's see. Remember the reaction. So the reaction here we say is the chlorination of ethane. So ethane is C2H6. Okay, I draw out C2H6, right? Then you plus chlorine, and it will give you, this is the overall reaction, to help you visualize, to form dichloromethane and your HCl, and then you would check for if it's balanced. Yeah, in this case. So you know that the chlorine radical can be, it can be either reacting with ethane or chlorine. So usually we will react with ethane first. So this chlorine radical, since it's so reactive, it will always go to react with a molecule, because it has a strong tendency to pair up with an electron of another species. So this is ethane, and no, we do not need to draw the whole thing. We can just express it like this, because all we need to care about is the first carbon. Alright, so now what we're gonna do is the carbon is gonna take one of the bonding atoms. Alright, and then one of the bonding atoms is gonna combine with your chlorine. Okay, and this will give you your HCl and your radical. This will be your radical. Okay, so now the second part is that this radical right here, it will go over. So I will use a green pen for rough working. It will go over here. It will go over right here. And another molecule that we haven't used yet is your chlorine. So chlorine right here, one bonding electron goes to one of the chlorine atoms, another one of the bonding electron of chlorine will go to the radical, and in this case it will help to form chloroethane. So with one chlorine and your chlorine radical, because your chlorine atom takes one of the unpaired electrons, one of the bonding electrons. just now. So this is just two equations. So to draw out the second set of equations, we will be using this one. Alright, so that you are able to form your final product. So plus your chlorine radical, and just know this is the one we're going to deal with. Alright, so the carbon atom takes one of the bonding electrons from the CH bond, and then the hydrogen will take one of the bonding electrons of the CH bond, and it will go and pair up with the unpaired electron of the chlorine radical, and give you the hydrogen chloride molecule as well as your other radical right here. And this radical right here, we're gonna bring it over so that it can react with another chlorine molecule. Hold up. Yeah. So one of the bonding electrons goes to the chlorine atom. Another one of the bonding electron will go and pair up with the unpaired electron in the radical. And this will result in oh sorry, my bad. This is chlorine. This will result in you forming your final product. And this is your chlorine radical. So notice how each of the equation it forms a radical. So in this case, this radical will always go back to the earlier equation to react with a molecule to form even more radicals. So in a sense, this is what you call a chain reaction. Yeah, it will always see the chlorine radical being consumed and then being regenerated, and then consumed and regenerated. And this is how you um this is how the reaction can sustain even with a brief exposure of UV light. This chlorine radical is being consumed and being regenerated in the second equation. So consumed in the first equation, regenerated in the second equation. This shows that it's a catalyst. Okay? And it means that it will be able to speed up the rate of the reaction. And then what we have next is termination. So termination involves two radicals to form a molecule, and that's how you stop the reaction, because you prevent even more radicals from continuing to react with molecules in the propagation step to form even more radicals. So in this case, you want to stop reaction is that you have these radicals react with each other. So this is one of the ways, chlorine radical and chlorine radical. Then another way is you have your chlorine radical and another one of these radicals. So you only need 3 of this. Okay? Okay, so as you can see here, these are the 3 termination steps, and yeah, that's about it. Okay, there's even more of these steps, so you can use other type of radicals to continue reacting, such as you can use this one. Yep. And then you can use that one to react with even more of these radicals to form more of to form the molecules that you need. Okay. All right. That concludes organic chemistry. So yeah, that's about it. So hope you guys enjoyed the video package of organic chemistry and understand something. Um, if you have any questions, do feel free to ask me. Okay? All right, that's it. Goodbye.